Third one, magnetic particle. Only works for 3 metals: iron, nickel and cobalt, because they are the only 3 magnetic metals. Magnetic particle testing puts a north pole here and fires a magnetic field down here to a south pole through a piece of sheet metal this is commonly used in. The very first, one of the very first jobs I had is doing this. Just imagine having kerosene full of red magnets, little red magnetic particles, and you spend all day splashing it over and you walk home smelling like kerosene. So what this is, on the surface, we just put, wrong, go back one, magnetic fields. If there's nothing, the magnetic field travels parallel. Yeah? Here, that one's travelling along until it hits here, then it goes out the surface. That one goes underneath, and it makes a little perturbation in the magnetic field. Little bump in the magnetic field. This one goes around it, and it just generally creates just a tiny bump that's really hard to see. Yeah? Visible, but so difficult to see it's impossible to really find easily. Things that are 90 degrees to the field show straight up, like nothing else. If I've got kerosene over that with magnets, they literally stick out there like that. You cannot miss the fact there's a defect. When you make steel, it's sometimes got bits of the slag inside it and the stuff from the furnace, the silica, the slag, the calcium from the blast furnace gets trapped in it, gets rolled into the steel and comes through inside, in between all the grains. That's really bad if you want to make tin cans or if you're trying to form a car body panel, because it's a stress raiser. It initiates fracture. Because ceramic, obviously, if you've got sand and steel, the sand will just shatter when you try to stretch it. Yeah? So this is great for detecting cracks at 90 degrees to the surface. It's only so-so for detecting cracks that are parallel to the field. There's a common theme here I hope you're seeing. So that's mag particle tests.